Hi, I'm Jason Kane, and today we're going to talk about integration by substitution. So integration by substitution, or as we call it, U substitution, or the reverse chain rule, is one method for finding the integral. We begin this method by determining which part of the function is going to be substituted for u. Then we can make u equal g of x and integrate f of u du. Lastly, we finish by reinserting g of x where u is. Hey everybody, we're back with 6.2 substitution examples, and we're going to go over our first example of the integral of 2x plus 5 to the power of 10. So what we're going to want to do first is get our u substitution. So how we're going to do this is we're going to take what's inside the parentheses here and do 2x plus 5. And then you want to do your derivative. So you take a derivative of this, it'll be 2 dx, and that's going to equal du. And now you're going to want to divide everything by 2. So it'll be a half du equals dx. Now with that, you're going to move this half du back to the top. And you're going to take the integral now of the half du. And see, we're going to choose our power, or to the 10th power here, and bring it down and attach it to the u. This will also be at du. And then you're going to do the power rule of this of the 10. So it will become u to the 11th, which will also, and then we're going to have our half du. So, and then what you're going to want to do now is divide this 11 by the half. So now you're going to get 1/22 u to the 11th. And don't forget c. And then to finish off the problem, you're going to go back to the original problem you have here and go 1 to the 22nd, 2x plus 5 to the 11th, and of course c. And that is how you do this problem.
Alrighty, so we have another problem here, another example. So this is the integral of 5x plus 2 raised to the 7th power dx. So first what we're going to do is we're going to take the derivative of what is in here. This will be our u. So over to the side we can write u equals 5x plus 2 just for convenience sake. So because this is our u, we're going to take that derivative, which is ends up being 5, so we're going to rewrite our equation, and we're going to have 1/5 and then 5x plus 2 to the 5th dx, okay? And then this is technically timesing it by the 5 dx. So then what we're going to do with this is obviously our u, so we're going to do 1/5 of the integral and then u to the 7th du, so we're substituting here, which is important to remember. And then lastly, we're going to integrate. So it's going to be 1/5, integral of u to the 7th du equals 1/5, and then u to the 8th, because this is the power rule, so we're adding 1, and then over 8 plus c. Always got to remember our c. So now what we're going to do is we're going to substitute this u back in right there and there. So it's going to be 5x plus 2 to the 8th over 40 plus c. And that's how you do it. Alright everybody, so lastly, this is just kind of like a little review section of what we've just gone over, but substitution is known as the anti-chain rule. You'll definitely have some trial and error in deciding what section can be substituted for you. It can be as easy as like our 5x plus 2 example, or more challenging. But if you do some trial and error, you will end up determining which one is which. So you will also write u as a function of x, gotta remember that, and then you take the derivative du dx and solve for the quantity dx in terms of du specifically. And then you use whatever expression you get from your second step, and then you substitute that back in for dx in the given integral, and then you substitute u into the original expression. And then just a couple applications of substitution is basically just plugging into cost functions in order to find our C value, which is obviously that constant. It's very, very important to remember to include C at the end, or in some instances, like finding that cost function to find C, because in a business example, you need to know what your costs are. It can definitely make a big impact. And yeah, so homework questions to definitely review would be number 1, 2, 4, and 5. And then right at the end of the screen is the formula. So remembering that for the exam is also very important.